Alright guys, so continuing onward here, now we gotta put some language to what we've been doing. So we see here that we have some things: scale factor, enlargement, reduction. So let's go ahead and define these guys. So scale factor we refer to as our K. So basically what that is telling us how much the sides are getting bigger or how much they're getting smaller. Okay, so scale factor, we could define this as the value all side lengths are multiplied by. And again, as us with mathematicians, always got to put things as a letter. That's what we call our K. Alright, so K is our scale factor. The values all side lengths are multiplied by. Then from our K we determine whether it's enlargement or reduction. So much like if you think back to our transformations, whether it's like stretch or compression, we're looking at those things here. So enlargement, think of this like Ant-Man. So enlargement, when he gets bigger, that's enlargement. So gets bigger. Ant-Man can get bigger or smaller, so he enlarges when he gets bigger. And so our K value would be greater than 1 when we have an enlargement. Then reduction, like when he shrinks, he gets smaller. So reduction is gets smaller. Or our K is going to be less than 1. If our K value is 1, we're not doing anything. We're just staying the same. So we're going to go ahead and look at these guys. So, or we'll put this in action. So if we look at A here. So we're going from, going from, if we look at going from this triangle here to this one here. Okay, we can assume that all these are similar. So each one of these is similar. So we got to look at and see which sides correspond. So this side right here, that's our hypotenuse. So that's our longest side there. But we don't have a value for that, so that doesn't help. And then we have, this is our smallest side, 18. So 18 corresponds to 12. That'll help us to know what's going on here. Helps us figure out what our K value is. So since we're going from 18 to 12, we're getting smaller. So that would be a reduction. So we're going from 18 to 12. And so then to figure out what our K is, since we're getting smaller, we know our K is either going to be 12 divided by 18, or K is going to be 18 divided by 12. But again, we're reducing, so we're getting smaller. If we look at this second one here, 18 divided by 12, that's going to be greater than 1, and since we're getting smaller, that doesn't work. Meh. So what we're going to have to do, we're looking at the second one. I'll erase my reduction here and I'll rewrite it later. 12 divided by 18, that gets us 3/4, or 0.67. So our K is equal to 0.67, and that's a reduction. So we can look at that. Let's hop over to C here. I'll leave B for you guys to do. Again, we're going from the one on the right to the one on the left. So we're coming from this one to that one. Now we gotta see what sides are similar. So we gotta kind of tilt and rearrange this. So we know this side's one of our longer sides, so we know this corresponds to that one. Again, because with them being similar, it means that whatever's smaller is going to remain smaller, and whatever's bigger is going to remain bigger. Okay? And again here, we're going from the one on the right to the one on the left, and we're getting bigger, so that's going to be an enlargement. And so our K is going to be, we know it's getting bigger, so we take 28 and divide it by 7. And so that is equal to 4. So we have an enlargement, and our K is equal to 4. Awesome. So that's how we do that. Keep looking down here. So now we're going to get into things a little bit more complicated, but we're kind of meshing together what we did up here with our scale factor and then our triangles. So we're wanting to find, if we look at A here, let me switch colors. Let's go yellow. Why not? Find height. So we're wanting to find the length of HI. So we're wanting to figure out what that length is. So these triangles, again, are going to be similar because this angle's the same. And since these points are along the same line, that angle is going to be the same. And this angle is going to be the same. So that's how we know they're similar, as long as they're along the same line. So we could write this, that triangle, let's go TUS, is similar to triangle TIH. So knowing that, if we look at just side lengths, we know the length TU is similar to the length TI. But we can see that with these double lines here, that means those two lengths are similar. So this length TI is the exact same length as IU. So TI is exactly the length of IU. But TU, so we know it's going to be TI and then IU, so that is going to, so TI, oh, sorry, TI, oops, what am I doing? What am I doing? So again, TI plus IU gives us length of TU. So since TI and IU are the exact same length, that means TU, the length of TU is equal to 2 times the length of TI. Okay, so we know the length TU is 2 times the length TI, so this 2 here gives us what our scale factor is. So we know that if we're wanting to find HI, let me go back to yellow, then we know SU is 2 times the size of HI, because since these triangles are similar, the scale factor is the same, so we know our K is equal to 2. So to figure out what the length of HI is, we just take 10 and divide it by 2. So then we get 5. So we know the length of HI is 5. Okay, these get a little bit more complicated, but if you look, whenever we have a triangle set up, like if we look at B, where those two sides are similar, so that means that this whole length is 2 times the length of this guy, because we got the same length here and the same length here. So whenever we see a triangle set up like this, it means that our K is 2. So here, if XZ So xz, the length of that is equal to 16. That means the length of CD is equal to 16 divided by 2, which is equal to 8. So CD, the length is equal to 8. Okay.